level, that is quite a long method that we've just been using, where we've been working out from the full equation, the ionic equation, and from the ionic equation, the half equations, then looking at those to decide who got oxidized and who got reduced. There is a much quicker method, and it's called using the oxidation states. So what is an oxidation state? Well, an oxidation state is the number of electrons involved when an atom forms a bond. So when sodium forms an ionic bond, it gives away one electron to become a sodium 1 plus ion. Its oxidation state would reflect that, it would be +1. When water, the oxygen in water is forming those bonds between the hydrogen, the oxygen uses 2 electrons to form bonds to the hydrogen atoms. Its oxidation state takes account of that, and that its oxidation state is a 2, it's a -2, and that's for reasons of something called polarity. So the oxidation state refers to one atom in the compound. So in water, the 2 hydrogens each have a value of 1, they each use 1 electron, but there's 2 of them, okay, and it has a number and a sign. So it's either positive or negative, and it has a number. So we would say something like +1 or -2. These would be oxidation states. And you need to learn some rules for assigning oxidation states. And once you've got these rules really firmly solidified in your mind, you'll find this whole topic much quicker. Okay, so rule number 1 is uncombined elements. So when they join to themselves, we don't count those bonds. So uncombined elements have oxidation state of 0. So if we just look at an element like sodium, it isn't forming any bonds, we say that element is oxidation state 0. Even in something like Cl2, each Cl is still 0 because it's an element. O2, F2, Mg, any element, you can pick any element, carbon in diamond, and you can just say oxidation state is 0. So uncombined element always has an oxidation state of 0. And rule number 1 is probably the most forgotten rule. Okay, so it is rule number 1. Element is 0. So if it's not in a compound, it's got an oxidation state of 0. Rule number 2, we've got to learn some common values for oxidation states. So rule number 2, some things have the same value, so some elements have the same value in all their compounds. So the group 1 metals, when they form compounds like sodium chloride, sodium oxide, potassium bromide, then every single time they will have an oxidation state of +1, and there are no exceptions to this rule. So in NaCl, the Na is +1, and what we're going to learn later is to balance that out, then the Cl would be -1. If we looked at something like Na2O, because we know that the Na is always +1, and we've got 2 of those, we're going to work out that the O must be -2. Now what you might be spotting is these are very similar to the charges on the ions in these ionic compounds. So group 2 elements are always +2, and again there are no exceptions to that rule. If you're in group 2, you are a +2. So in magnesium sulfate, the Mg is +2. Now the sulfate is not one thing, so we will have to consider what the sulfur and the oxygen are in sulfate. If we look at something like calcium chloride, the calcium is always +2. Each chlorine in that is -1. The group 3 elements that are metals are always +3, so aluminium is, say, aluminium chloride or aluminium oxide. So the metal elements in group 3 are +3, and there's no exceptions to that. Hydrogen is pretty much always +1, so in things like HCl, it's +1. In H2O, it's +1, there's just 2 of them. And we can look at what the oxygen would be as a result of that. But there is an exception. Except in hydrides. Now hydrides are things with metals, so like e.g. NaH, and the reason that there can't be +1 there is because sodium is +1, so the hydrogen has to be negative. So in that the sodium is +1 but the H is -1. And hydride iron, hydrides are H- iron, so that kind of explains why they'd be -1. -1 in those. That's our exception there. Fluorine is always -1, so NaF. We know that the Na was +1, the F is -1. Or something like calcium fluoride, because we know that the calcium's +2, we know that the F is always -1, and that's how they balance out. And there are no exceptions to that. Fluorine is the most electronegative element. It can only ever gain 1 to get a full shell, and it can't be positive because it is the most electronegative element. Oxygen is -2, so in things like water, the oxygen is -2, each hydrogen is +1. In something like Na2O, each sodium is +1, the oxygen is -2, except in peroxides, so like your hair bleachers and things like that. So something like H2O2, what would the oxygen be in that? And in that, the oxygen would be, if the hydrogens are +1, the oxygen would be -1. And that is actually, if you understood the structure of peroxides, which is not on the A-level syllabus, because one of the bonds in a peroxide is a bond to another O. So although the oxygen makes 2 bonds, one of them's to itself, another oxygen, and that we don't count that one, it's oxidation state. And then chlorine is always -1. So in NaCl, it's -1 because the Na is +1. And in something like MgCl2, there's 2 of them each at -1, except when combined with oxygen, who's more electronegative. Yeah, so when we come, I'm going to put that O up there actually, so that we've got our EGs down here. So in something like NaClO, given that we know that the sodium is +1 and that chlorine is, oxygen is -2, what's the chlorine? The chlorine would have to be +1 to balance out that charge. Okay, so we've got +1. So it varies depending on the compound. It won't always be +1, because in NaClO3, in this compound, each oxygen is -2 and the sodium is +1, which leaves me my chlorine to be +5 to balance it out. So it will depend on what it's with. So that's rule 2. So we need to learn some things. Group 1 +1, group 2 +2, group 3 +3, hydrogen +1 most of the time, fluorine -1, oxygen -2 most of the time, chlorine -1 most of the time, but this one is going to make an appearance. This exception, this one we do need to bear in mind. Okay, so let's just put a little star at the side of this one. This exception is the exception that we're going to have a look at in group 7 chemistry. So rule 3 is, we've already started to look at, for a compound, the oxidation state of each atom counts separately, and we're going to add it up, it's going to become 0. So if I were to show you NaCl, we know that Na is always +1, we know that Cl is always -1, numerically if we add that up we get 0. So then we can use that to find ones that are not in our table. So if I said to you, what's SO2, what's the S in SO2, we know that oxygen is always -2 and that the numerical sum is going to be 0. There's one S in there, so what's the charge on S? Well, something take away 2 is 0, that something is +4. So we can find ones that aren't in our table this way. So that's sulfur dioxide, whereas in sulfur trioxide, the sulfur is actually going to make 6 bonds and not just 4 like it does in sulfur dioxide, in order to get that numerical sum of 0. That's rule 3. Rule 4, for elements that exist as an ion, so if we're writing an ionic equation and we see something like Na plus or O2 minus, these are elemental ions, so the sodium ion, the oxide ion, the fluoride ion, the magnesium ion, these are just elements, so not more than one thing, just one thing, but existing as ions, then the oxidation state is the same as the charge. But if the element were just existing as the element, so Na or O2 or F2 or Mg, then the oxidation state would be 0 because that's rule 1. It's only if it's an ion, it's the charge on the ion. And then rule 5 for compound ions. So compound ions would be things like your sulfate ion, your carbonate ion. Then this time we're not going to add up to 0 because there's a charge. We're adding up the things in the compound ion to add up to the charge. So we know that oxygen's always -2, and we've got 4 of them. So what's the sulfur? Something take away 8 is -2, then the something must be +6. What's the carbon in this? Because we don't know what carbon is, it's not in our table. So we've got 3 lots of -2, we could do it like that to save on space. What's the carbon? Must be a positive number to balance out the negatives, and it doesn't equal 0, does it? It equals -2 because of the charge. So something take away 6 is -2, that something is a +4. Try that again, +4. So compound ions. Right, you can work them out. See if you can work out the oxidation state of an N in a nitrate ion. And if you've done that correctly, you should have got, for the N, +5. Because each oxygen, there was 3 lots of -2, and we were trying to equal -1, because the charge was -1. So there are some questions here for you to have a go at. So pause the video now and have a go at all of these. If you've done that, you should have got these answers. So the first one, calcium is always going to be +2 in a compound. The only exception there on that first line is where it was an element, and we know that rule 1 says when it's an element it's 0. B, again, where it's an element, chlorine is 0, but chlorine is -1 unless there's an oxygen there as well. So the number 3 and number 4 have got an oxygen present, so we've had to work those out. Remember, we're working out the charge, the oxidation state on the chlorine, and in sulfur. We've gone through doing those, and bearing in mind that we know the value for oxygen and we know the value for calcium, we know the value for sodium. That is how we've been able to work out the value for sulfur. And then on these ions at the bottom, so we're using the last 2 rules at the bottom there. You can practice this in your study pack. There's plenty of questions for you to practice assigning oxidation states.